Okay guys, so 8.2 is angles and radian measure. As far, I don't know, I think this might be our last section that we do, but we could go on to 8.3 once I get back from maternity leave. I'm not really sure how that's going to work yet, whether we'll be face-to-face or still digital, but 8.2 is angles and radian measure. This is one of the easiest sections. I think you guys will catch on pretty quickly. It says the angles in standard position. This is really important. An angle in standard position, it has two sides. One is the initial side and one is the terminal side. The initial side always lies right here on the positive x-axis. And then your terminal side is the side that terminates your angle. So that's where it ends. You'll always draw the terminal side differently, but the initial side is always right here. Okay, so also you can notice that we label the axes here 0 degrees, that's our starting point, and then it goes to 90, 180, 270, 360. So 0 and 360 are on the same line. So it says the measure of an angle is positive when the rotation of its terminal, and that should say side, when the rotation of its terminal side is counterclockwise. So meaning it goes up first, just like it did in this one. And it's negative when the rotation is clockwise. So if you start here at this initial side and you go down first, that's when it's negative. So when we draw angles, I didn't cover these up because I kind of just want to talk about them. Let's see, let me get a highlighter or something. Okay, so if we look here, drawing an angle or a 240 degree angle, your initial side is always here. Okay, and then 240, that's between 180 and 270, so you just draw your terminal side somewhere down through there. And then your arc starts on your initial side and goes in the direction that it should. So this is positive, so it should go this way. And it'll arc over here, and you'll have like a little arrow on the end. So for 500, 500 is greater than 360. So what you have to do is you'll do 500 minus 360, and that gives you 140. And this is the angle that you're going to draw. So we'll have our terminal side, or our initial side, sorry. 140 is the terminal side. So it's between 90 and 180. So we draw that line here. And then now our arc is actually going to be a squiggly line because it goes all the way around one time and then back to 140. So that's why you'll see that squiggly line there. So negative 50, we still have our initial side, but remember negative angles go clockwise. So it starts at 0 and then negative 90 is down here. Negative 180, negative 270, negative 360. So we start here and we're going to negative 50. That's between 0 and negative 90. So we just draw it somewhere down here. It doesn't matter where. And then we'll have our arc going in this direction now because it's negative. Okay, so I want you to pause the video and try these 4 on your own. Okay. If you pause the video, 65 degrees should look like this. So you're still starting that initial side here, and 65 is between 0 and 90. 300, same thing, starts here. This time it's between 270 and 360, and your arc goes counterclockwise again. Okay, now we have negative 120. It should look like this. So our initial side is here. This time we number backwards if you want to call it that. So it'll be negative 90 down here, negative 180, and negative 120 is between those two. So that's why it's like that. Negative 450, you're going to have to, you'll have negative 450, but instead of subtracting 360 this time, we're going to have to add it because we want it to be a smaller number, not a larger number. So if you do negative 450 plus 360, we'll get negative 90. So this one, let me draw this one with you. So we'll have our initial side here. Okay, we do negative 450 plus 360 is negative 90. So that's straight down this way. Sorry. Our arc starts at the initial side, goes down and around for 360 degrees, and then plus another 90. So it should look like that. Okay. So it says, in example 1b, the angles, first of all, let's find that. Where's 1b? Here's 1b. This one right here. The angles 500 and 140, those are called coterminal because their terminal sides are they coincide. They lie on the same number, or they look the same. Just like number 4 right here, negative 450 is a coterminal angle with negative 90 because we're technically drawing a negative 450 degree angle, but that terminal side is the same as the negative 90. Okay, so it says an angle coterminal with a given angle can be found by adding or subtracting multiples of 360. Because if you think about it, if you have a 60 degree angle and we add a full rotation, that's going to end in the same spot. So that's why we do that. Negative 45, if we add 360, that gives us 315. So we want to find one positive and one negative angle that are coterminal with the angles given. So we have negative 45 plus 360 gives us 315. So 315 lies on the same side as negative 45. And then if we do negative 45 minus 360, that's going to give us a negative coterminal angle at negative 405. So 315 and negative 405 are the two coterminal angles. Okay, so you have 395. 395 minus 360 is 35, and minus 360 again is negative 325. So this one was a little different, and I forgot to preface with this. You can go ahead and add 360 if you want, and it'll give you a positive angle as well. But as a note, if it's greater than 360, if you go ahead and subtract them, just subtract 2 of them, it'll still give you one positive and one negative. So that's a way to do that. So I want you to go ahead and try 5 through 8. Number 7 is greater than 360, so you can subtract 360 twice if you want, and that should give you what you need. So 80, you'll get 440 and negative 280. 230, you'll get 590 and negative 130. Now 240, if you subtract 360 first, you get 380. That's a positive one. If you subtract 360 again, you're still going to get a positive angle at 20 degrees. So then you'll take 20 degrees and subtract 360 and you get negative 340. So essentially you just want to add or subtract 360 until you get one positive and one negative. Negative 135 is 225 and negative 495. Keep in mind there are multiple answers that would be right on these. If you have one, as long as they're correct and like you're just adding and subtracting 360, I'm fine with that. They don't have to be the exact ones that I have. Okay, it says angles can be measured in radians as well. So radians. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So the important thing to know about this, it says because the circumference or the distance around the circle is 2 pi, there are 2 pi radians in a full circle. So degree measure and radian measure are related by the equation 360. So one full rotation is 2 pi radians, and half of a rotation at 180 degrees is pi radians. So just 1 pi. Okay, so we can convert between degrees and radians. It's super simple. If you're going from degrees and you want to end in radians, you're going to multiply by pi over 180. So you can just write pi over 180. And it's just the opposite for radians to degrees. So you multiply radian measure by 180 over pi. So if you start out with radians, this is how you multiply. And I'll show you why in just one second. So example 3, if we convert the degree measure to radians or radians to degrees, part A, we start out at 120 degrees. So degrees should not have pi in the number at all. So that means for radians, we want to have pi in our answer. So in order to do that, we'll multiply by pi over 180. And we just multiply straight across. So we have 120 pi over 180, and you just have to reduce your fraction. So 120 over 180 reduces to 2 over 3, so you'll have 2 pi over 3. So for part B, we started with radians, and we want to go to degrees, so we want to get rid of the pi. So we multiply by 180 over pi. Okay, so those pi's cancel out. That gets rid of that. Then you're left with negative 180 over 12. We multiply straight across. Negative 180 divided by 12 gives us negative 15. And that's degrees now. So pause this, do these 4 on your own. And I made a note on number 12 that it is in radians already. It just doesn't have a pi. So I want you to go ahead and convert that to degrees. So 135 you'll multiply by pi over 180. And that reduces to 3 pi over 4. Negative 40 degrees multiplied by pi over 180. That reduces to negative 2 pi over 9. Now 11 is already in radians. We want to go 2 degrees. So we'll multiply by 180 over pi. And the pi's cancel. You get 5 times 180 is 900. And 4 times 1 is 4. 900 divided by 4 is 225. Okay, if this is radians, we're not going to have any pi's that cancel this time, but it will end up going away, because if we multiply by 180 over pi, we're going to get negative 1130.4 over pi. And if you type that in your calculator, you get negative 359.8. Okay, degrees in radian measures of special angles. This is how that unit circle looks. You'll talk about this a lot and in detail next year when you have Miss Parsons for Math 4. She does a whole unit on the unit circle, and it will be burned into your brain forever. So here's just a little glimpse of it. We won't necessarily be using it now, but you can memorize it, or we can just convert them. It's not going to change much. All right. So it says, a sector is a region of a circle that is bounded by 2 radii and an arc of a circle. So that makes no sense to you right now, but it will. The central angle theta of a sector is the angle formed by 2 radii. Okay, radii, those are just 2 pieces of a radius. So there are simple formulas for the arc length and area of a sector when the central angle is measured in radians. That is important. This central angle has to be in radians before you can do these. Okay, so here are the formulas. The arc length is S equals R theta, and area is 1/2 R squared theta. You do need to memorize those for this section, but obviously we're online and you'll just be able to look it up. But I would also still try to memorize them. So this is what we're talking about. This shaded region here is what we would be finding. This is the sector. The arc length is from the first radius to the second radius right here. And then this is our central angle, which can be given to you in radians or degrees. You might have to convert it. I will start example 4 in the second video because I'm running out of time on this one.